This is the Peter Schiff Enterprises H6 turbocharger, and it's a very delicate, very tight tolerance assembly. The oil inlet is right here. We want to cap it so that no debris ever gets in here. When we remove this plug here, it's a 1/8 inch NPT fitting. You will see a snubber in here that restricts the oil flow to about 5 milliliters, 5 to 10 milliliters per minute. We don't want excessive oil flow. It makes the oil foam, and it slows the turbo. The pressure switch, the oil pressure switch, is placed into this by wrapping tape, Teflon tape, only on the threads, never on the end of this assembly, so that we don't shed any tape. You notice there's nothing on the end, and we will attach a pressure transducer like so. We never excessively tighten this, because if we loosen the epoxy fitting here, the entire assembly has to be returned to us to remove any debris and to reattach it. So in order to tighten it, we will hold this T and then tighten it like so, so we do not put any torque on that fitting. So this is moderately tightened like so, and then the turbocharger fits into this carrier like so, and the ends have to be aligned so that this end goes to the pressure regulator at the right angle, like so, and this end goes to the heat exchanger in the aircraft. You will notice that there are different orientations, making most any angle available for the turbine side and the compressor side over here. In order to clock this turbocharger, we use a good circular plier, and we simply compress the circlip ring, and you'll notice that this whole thing will rotate freely, and we make sure, absolutely sure, that this is fully seated in the groove, because if it isn't, this wheel will rub on the housing and it will destroy the balance and cause the turbocharger to fail. The same thing applies to the compressor side, where we also have a circlip ring. And if we loosen that, likewise, we can rotate the bearing housing in the compressor housing to achieve just the right angle, going to the pressure regulator over here, and this going to the heat exchanger. The turbocharger has a lot and model number on this plaque, and if we remove the turbocharger, the easiest thing to do is to remove these Allen screws right here, these screws, and then remove the brass intake from the turbocharger. This is more difficult to unscrew. Every screw going into the turbocharger has an anti-seize, and only this Permatex anti-seize should be used. That is put on all the screws, and the screws holding the turbocharger into this carrier. Right. Going forward then, this assembly is moderately tightened in here, and again, we use this on the threads. This should not require any retightening or anything like that. And of course, going into the turbocharger side is our pressure transducer, which is connected like so, and the anti-seize being here, and anti-seize is used on these threads if this is ever removed. Normally, we just unscrew this assembly from here, but if we ever do, we must remove this tensioner. This has to be removed first because it will prevent the rear dome from exiting from this assembly. So when I unscrew this, this can now go back through and out. And again, we use the anti-seize compound on here. This is a tensioner. It's spring-loaded, and it's brass. So only moderate tightening. If you tighten this excessively, you will shear this assembly and break it in two, and it becomes a problem. The turbocharger has an inflow hose, a braided hose like this. And again, when we tighten this fitting on here, we must hold this fitting here with one wrench and that with another one so we don't torque the inlet side to the turbocharger. The outflow from the turbocharger has a clear Teflon hose that attaches here, and it also attaches to the oil system over here. The only type of hose clamp to be used is this style, which is available from us. One here and one at this end of the oil system. The way we shape this Teflon hose is that we apply heat like this. I'm going to apply some heat to it. And you don't have to use MAP gas. Ordinary propane works. And it becomes more clear as it gets hotter. Right? So this is now ready. And we apply a little bit of a Teflon-based lubricant to this. And we stretch this over this mandrel like so. Once it cools, we can push this off here, and we have an enlarged section like so. So I'm going to accelerate. It hasn't really cooled yet, but you have an enlarged end. If we want to bend this, we will put a spring inside of this and a spring over on top of this. Then we heat this, put the spring on, bend it, put it in cold water, and then it will hold its shape. The whole process is done, so we have a continuous slope, a down slope from here, from the turbocharger, all the way to the fitting over here, right? Now, if the system has become contaminated due to a failed turbo, this line will have black oil in it. That means we have debris in the oil system. And what we do, we remove this whole oil system from the aircraft. There are at least 2 screws on each side, preferably 3. And removing this, we then drain the oil, remove all this hosing, and we remove this pre-filter. And in this assembly, we remove the 10-micron filter, like so. This whole assembly comes apart. We use Viton filters, and the whole thing, first we rinse it, of course. After we're done rinsing the whole system, we reassemble this, like so. Of course, we don't have to remove this. This will be in place. We retighten this rather tight. And then what we do, we recirculate the oil like so before we connect this to the turbocharger. We want to flush this. So any debris gets caught in the filter, any debris in this line, and only after about 10 minutes of operation, we then connect this to the turbocharger. But again, you run it like this for at least 10 minutes, and in order to make the pump run fast, we shorten this terminal to that terminal, like so. These are connected with a pair of needle nose pliers. You never touch the center terminal. If you connect the center terminal to either one of these, you will destroy this pump module. This makes it run fast. And I'm going to demonstrate that operation very simply by connecting a power supply. Take just a second here. Of course, it's polarity sensitive, like so. And turn on the power supply. And the unit is pumping slowly right now. You can see the oil flow. When I short these two terminals, I'm going to do it with a clip lead. You can hear the thumping. Oops, I'm losing oil here. When I connect these two outside terminals, you can hear the pumps quickly, and our oil flow is vastly increased. So when I connect these two, like so, you'll see the oil flowing much more quickly, right? And I do this after maintenance to really flush the system out, and only then, after this has been run for about 10 minutes, will I connect this to the turbocharger. Now, the flushing must be done with either methanol or isopropyl alcohol very, very thoroughly. Flush the heck out of it. And I would not run this system with alcohol. I would only run it with oil. But prior to doing that, it will have been flushed thoroughly with this pre-filter disconnected, with this filter taken out. Then I will dry the system out with some dry nitrogen, and I will connect these filters and run the system like this outside of the aircraft, install it in the aircraft, bypass the turbo again, and I'm ready to go. The oil system is a pretty intricate mechanism. What it does, it's not only an oil supply, but it will separate the oil mist from the turbocharger into oil and air. The air outlet is connected here, and this plug is not just a plug, it has a calibrated orifice to maintain a certain airflow and make the whole system work as an oil separator. It's a very sophisticated circuit. The oil level, we don't see it here, but there normally is a blue band here and a blue band here. We keep the oil level between the two blue bands. Normal oil consumption is about 2 cc's of oil per hour of aircraft operation. And that oil level should be checked every 15 or 20 hours to make sure that it has not depleted. If the turbocharger uses a lot of oil, that means the bearings are worn and the wheels in the turbocharger are displaced, creating a suction that draws air out of the turbocharger. Okay, got it.